Hello everyone, my name is Ismail. Today I am giving a demo class on gravitation. So let's start. What is gravitation? So let's discuss something before it. So, would you be surprised if you let go of a pen and it didn't fall? So, this is not normal. So, we will be surprised by that. So, have you ever thought why do things fall? So, Newton described it as a force that exists between objects with mass. So we might think, why does the moon orbit around the earth? So he concluded that a force acts to pull objects straight down towards the center of the earth. So this is the reason why things fall. So he described gravity is a force that pulls objects towards each other, anything which has a mass. So the universal gravitation law was framed by Newton. So he told that gravity acts everywhere in the universe, not just on Earth. The law of universal gravitation states that the force of gravity acts between all objects in the universe. This means that any two objects in the universe, without exception, attract each other. As I stated the universal law of gravitation of the Newton, you might think that Earth and the objects around us are attracted to us as well, but it's a very small compared to the force of Earth's attraction. Let's discuss factors affecting gravity. The most important factors affecting the gravity are mass and distance. Mass is a measure of the amount of matter in an object. The SI unit of mass is the kilogram. So everything that has a mass, it is made up of matter. The more mass an object has, the greater its gravitational force, because the sun's mass is so great, so it exerts a large gravitational force on the planets. Okay, that's one reason why planets orbit the sun. In addition to mass, gravitational force also depends on the distance between the objects. Okay, the farther apart two objects are, that means the more the distance between two objects, the lesser the gravitational force. Okay, so let's take an example. If an spacecraft is traveling towards Mars, means outside the Earth, as the distance between the Earth and the spacecraft increases, the gravitational pull decreases. Okay, when the spacecraft is coming towards Earth, means the distance between the spacecraft and the Earth are decreasing, hence the gravitational pull increases and the gravitational force between Earth and the spacecraft increases. Okay, let's discuss what is weight and what is mass, how they are different. So mass is totally different from weight. So mass is sometimes comes confused with weight. Mass is a measure of the amount of matter in an object. So hence, but weight is the measure of the gravitational force exerted on an object. Okay, the force of gravity on a person or object at the surface of a planet is known as weight. Okay, so weight and mass are total. So when we step on a weighing scale, it shows the weight. That means the gravitational force Earth is exerting on us. Okay, so that's the force that we are experiencing from Earth. Okay, so the weight may vary from place to place. Okay, if we are on another planet, we will have a different weight because the gravitational force changes. Okay, the gravitational force changes from place to place. A person weighing 70 kilograms on Earth will weigh around 12 kilograms on the moon, because of the size of the moon compared to the size of the Earth. Until now we have discussed law of gravitation theoretically. So now let's derive it mathematically. So let F be the gravitational force. So let's take two objects of different masses, m1, m2. The distance between the center of their masses. Okay, let's consider this R. So the F is the gravitational force is directly proportional to the product of their masses. Okay, because as the mass increases, the force increases. So okay, so this is the theory behind that, because that's why we are using the product of the both the masses of the objects we are considering. And what we discussed earlier, as the distance increases, there will be decrease in the force. Okay, more the distance, lesser the gravitational force, lesser the distance, more the gravitational force. So that's what we have discussed. So now let's combining the both equations 1 and 2, we will get and the force that is proportional to m1 m2 divided by the distance between the objects. So we will consider but we have to find the now equation. So we will have an constant, that is the gravitational constant, and m1 to m2 by r. So this is the final formula for finding and force, the gravitational force that is between two objects with mass m1 and m2 and the distance between them is r. Okay, so from a lot of research and a lot of calculations, the gravitational g constant was found out, and the value is 6.67 into 10 to the power of minus 11 kg square per meter.